The usual, I want to go through a couple of slides just to acclimate folks. We've actually quite a few new people here today, so I really appreciate everybody coming out. And this is the best place to be. Look out the window right now and just go listening. So if we do lose power, just everybody be calm, hang out for a couple minutes, enjoy yourselves. You can figure out what to do from there. We'll do charades or something, with lightning as the background. So I want to thank Barracuda. We have a foundational sponsor. Actually, this is help me with the language, Jen. What type of sponsors? It's foundational. I get it. Excellent. Okay, so we have a foundational level sponsor here, and we really appreciate them being here for the year, helping us do the events. So please, send some business our way and let them know that you saw them here at AITP. All of these events take, in fact, we were talking about it on the table here tonight. All of the positions here on the board are volunteers, and like any of these volunteer organizations, it's a constant swarm of people putting their hands up and throwing the ball to the next person to get things done for all of these events. They look like they're relatively seamless out here, but there's a lot of stuff going on in the background. So just, if you see a board member, say thank you. There's a lot of effort that goes into all of this, and they are volunteering and doing it outside of their work hours. So thank you all. The same for our MAC. These are all volunteers as well. We have half of our MAC here tonight, which is great. And these folks give us advice at a board level and help us make these events and our organization much better. We have a bunch of new members here today. I'm not going to go through the full list, but if you are a new member, please raise your hand. If you do have questions, the board members, please, tackle any of us. I always have some ambassadors. We'll talk about those folks in just a minute. If you have any questions about AITP, or about and sort of the way we run our organization. Speaking of the ambassadors, Don, Ramesh, and Scott, I think all of you are here tonight. Great, thank you. I'm not going to spend a lot of time. A lot of these slides have been up running for the last hour, so hopefully people have taken a look at this. We do have a bunch of different membership options. So talk to Manish if you have questions on membership. Manish, excellent. This is one of the features in our membership option is that you can refer members, and you get a benefit for that if you are a member, and you also get a benefit for if you are a new member. So if you're interested, if you're here as a guest and you're interested, make friends with a member. It's good for you. It's good for the member. And again, you can ask Manish if you've got any questions. Instructions are right up here, but you can also ask Manish at any time or send an email to membership at AITP, and Manish will help you out with that. The other thing you can do is you can gift your membership. So if you can't make it on a given night, you can give this to anybody, and it's a fairly simple process. We've got a couple of steps that we lined up here. It's basically you log in as yourself, and then you put your member's name in and the email address. That first box that comes up, instead of putting your email address in, put the guest's name in that field and send it along. We have a couple of guests here tonight, so members are taking advantage of that. It's great if you're not able to make it. Once you do the investment, you can send your spouse if you want to have a night off. Or you can send a coworker if you want to do something like that. But leverage the capability there. We also have some membership groups for companies. So any of you that are managers in companies and you're thinking about ways you can deepen the relationship you have with your staff and your team, these are some ways to do that. Is the Group 5 membership. It's a great way for team building. It's a great way for doing educational components. And the key flexibility here is you can designate 4 different people every single month. So you can really tailor who's coming to the event based on the event. Maybe the team did a great job and you want to send them all out to dinner. It's a great opportunity to do that. Maybe the team is really interested in AI and fraud. You send them here tonight to talk about this. So it's very flexible from a manager perspective. And we've got a whole bunch of different companies that are doing this now. We're also branching out. NC State will be starting to join us. They've signed up for 2 of these educational ones that are going to be tailored to the academic year. So we'll have 8 students coming in starting this fall, which will be really interesting too. Should be an interesting group. We do sponsorship. Jen, happy to see you over there. If you've got questions on sponsorship, we love sponsors. It helps us do things off campus, as we call it, and we need at other locations. It helps us provide better food, all of those types of things take some funding. Sponsorship helps us do that. And obviously, during the sponsorship, we like to give back to the sponsors. You get advertising and you get exposure to the IT community here at Rocket. So talk to Jen if you've got any questions about that. Coming up in August, Tom Snyder will be speaking with us. This is the subject. The registration is open. So love it when people register early. It helps us lock in which room we're going to be. Most of you know we have a small room. This is it. We have a large room. We can lock in 50 or 60 people a couple of weeks in advance. It helps us have conversations about the larger room. With the NC State, the U club here. But Tom will be here next week to talk about this. This looks like an interesting topic. We haven't actually really talked about the Internet of Things much in this forum, so this is kind of a new space for us. And we still are defining our September program. We'll have something up here next month, and it'll be on the website as soon as we have that fully defined. But for October, we would like folks to start thinking about registering their time or setting their time aside on the calendar. This is becoming an annual event at Red Hat. It's a fantastic facility. And it's kind of fun to get to a new place and a new vibe. We'll have a sponsor for that. More information to come as it gets closer. And because it is off campus, we probably will have to close the registration early on that. So just again, we want to make sure people have got advance notice. And as soon as we can get that set up, we'll let everybody know. And then I wanted to go sideways here for just a second before we have our speaker come up. If you remember, we sent out a notice a little while ago. This is kind of a benefit for our members. We partnered with the Cybersecurity Summit, and in your emails there should be a code that you can use to register for free. It's about a $250 value, if I recall correctly, or something in the middle. So if you didn't get it, send a note back to us. We can resend the email to you, resend the pertinent information. But I encourage folks to join. It is one of the things that we can bring you as sort of a member of the community. And with that, slide. Your question? Thank you. Yeah, that's sneaky. Thank you very much, James. While I'm working on that, Anthony Edwards is here with us today. I'm going to be talking about AI for fraud. So I will get Anthony's deck set up. Hopefully you've seen Anthony's background. It's been up on the screen for a little while and you registered it and you saw it on the website. So this should be a really interesting topic. I got a chance to sort of look at this, the topic before, and I was listening to Anthony and Scott talk at a level that was way over my head about all sorts of other things at some point. So it should be it doesn't take a whole lot, but it should be a very interesting conversation. So Anthony, why don't you come on up while I get this situated? And for Anthony, please.
Well, thank you, Brooke, and thank you everyone for coming out tonight. I'm flattered that you are interested in hearing what I have to say. I'm going to buy time for Brooke for a moment. So I was working the crowd before the meeting. I tried to meet everybody. I'm sorry if I didn't get to meet you. But one particular gentleman, Mark Dronzak, apparently he researched me before this, and he said, your LinkedIn profile, your titles bounce all over the place. Software engineer, CTO, CIO, senior, that just bounces. I could joke and say that I'm filling out in my home, I'm filling out a bingo card of different titles. I still haven't had the title of VP, so that one's still open. But Mark said, why? Well, what's the story? What's your story? Well, there we go. And so I thought, why not? I'll tell you why. First of all, I love my work. I love working. And if I'm in a place where it does not match my talents, I don't want to be there. But what gets me up out of bed every day, and that's really what it's about. It's not about, okay, how much am I making? How much is this? How much that? It's about getting up out of bed every day and wanting to go to work. And I'm the kind of individual, compulsive this way, I like to match people with technology in a meaningful way. Okay, I can sell vacuum cleaners. That's technology. But vacuum cleaner doesn't have the, I'm not looking for a wow factor. So I like to join companies that are really making an impact on human condition, on our lives. These are the sorts of things. Because at the end of a project, if a customer doesn't say, wow, I'm really better off than I was before, I kind of pause and say, wait, should I be here? So, that's why I'm all over the place. Another reason why it's all over the place is because we have this driving need to to be an entrepreneur and work for entrepreneurial companies or start companies. It just drives me. That's what I want to do. The problem is they don't pay a lot. And one particular company, I'm not going to name it, but one particular company, I was their president for 16 months, and I'm holding all the money. I'm showing off all the money I earned for the 16 months, and I loved it. Loved it. My next job was Intel Corporation, and Intel just threw money at me. So I'm an entrepreneur I can be. Now, this particular company, I'm with AITC today, AITC Inc., and this particular company is paying me. It's a small company, and they are paying me, which I appreciate. But that's my story. I'm sticking to it. All right. So what I'm here to talk about. Oh, okay. So AI for fraud, fintech. That's the title of the talk. I have to ask you guys. So, is there anybody here from the FBI or law enforcement? Yeah. Is there anybody here who wants to learn about fraud and so they can practice it? Yeah. Look at this title. This title today, I'm like, AI for fraud. Are there people coming wanting to learn how to use AI to get fraud? So if you came to learn how to conduct fraud, well, I'd love to say you'd be disappointed because I'm not going to cover that. But actually, in fighting fraud, you have to know how fraud works. But I'm not here to teach you to conduct fraud. I, of course, do not endorse it. And the FBI guy will not raise his hand. So, or Eric. So, all right. So, what am I going to do? What am I going to talk about? Three things. First, we're going to talk about what does investigating fraud look like? What's the historical look like before AI, basically? Second, what does AI bring to fighting? And lastly, what I'm going to do is I hear that some of you folks are technical, so I'm going to go a bit more technical and actually look at a specific product. I'm going to look at the AC product called ADE, and we'll get into it. So that's the agenda. That's what we're going to try to accomplish tonight. And Brooke, you're watching my time, right? Yeah, great. All right. So first thing I have to do, aside from opening my notes, is we have to look at that word fraud. Fraud is a crime word. It's a law enforcement word. It's really not a corporate word, unless you're accusing an employee of fraud. So really, it's a little bit of a misnomer, not too much. How do corporations engage in fighting fraud? Really what it boils down to is a corporation, a financial institute in particular, IBM, I doubt, is feeding information to the government about fraud. But any bank, any financial institute is doing that. Now, they are required by law to, if there's any suspicious activity by any of their customers, they have to report it. So how do you figure out suspicious activity? These financial institutions have transaction monitoring systems. They're looking for suspicious activity. They have investigation teams, and then they report it to the government. So really, what financial institutes are doing is they're not really fighting fraud. They're investigating suspicious activity. So, but you and I both know that that's all part of the chain that is fighting fraud. Now, it's a cost center for a company. Companies don't earn money by investigating things that are suspicious. So, what do you do with a cost center? Try to minimize your costs. The government's got gotchas in there because you have to report a minimum number of suspicious activity, or they'll hit you with a fine. Or if you report too much suspicious activity, they hit you with a fine because you're being lazy and you're just sending too much information to them. So, and the guideline, the requirement is not specific about how much exactly they're looking for. So banks are kind of like, but let me give an example. if you a company not supplying enough information. We'll just say we have 10 banks. We'll say 10 banks in this area, and 9 banks are reporting things appropriately, and 1 bank is being lazy. They're not sending in information. So law enforcement gets the information. They see lots of money moving around. They see suspicious activity from banks 2 through 10, but they see very little suspicious activity coming out of bank 1. So they go in and they say, hey, money was transferred to your institute, and these other people say it was suspicious. Show me that what you did with that transaction. Why did you not think that was suspicious? And so they get fines because they're underreporting. On the other end of the spectrum, say bank number 2, they're skimping. They're very low cost, so they are not reporting. They're reporting too many, just keep pushing them out the door. Well, that generates work for the government. The more stuff you feed to them, they've got to work that out. You got to eliminate that. So they'll hit you with a fine for that too. And when I say hit you with a fine, we're not talking a parking fine of $100 or $200. In 2012, there's a bank, not so big in the United States, but definitely in Europe, HSBC. They were hit for a fine of $1.2 billion because of their sloppy fraud investigation. So, although you are trying to minimize the number of investigators, you have to pay the investigators. Investigators aren't that much. Really, it's the fine that you're watching out for. So that's kind of setting the pace, setting the stage. All right, so what's it look like? Oh, I forgot to mention to you. Questions. If you have a question during this, happy to take questions. Let's keep questions to what's on the slide, and the questions that aren't necessarily on the slide, let's hold to the end. We'll have Q&A there. Right. So what does anti-money laundering look like to a financial institute? So all the way on the left over there, of course, it's a financial institute. They have a database with their transactions. The transaction goes through a transaction monitoring system. Now this is something like NICE Actimize, Comply Advantage, FICO, Oracle, and SAS both have offerings. There's a bunch of TMS systems out there. The TMS system is responsible for looking at those transactions and generating alerts. This is potentially suspicious. TMS systems are also configured, so it's not like the vendor puts rules into the system. And 6 months later, a year later, when the fraudsters are doing something different, you got to change your rules so you can pick up the new fraudulent activity. So it requires care and feeding. But it generates alerts. Once you have the alerts, you send them over to your investigation team. The investigation team has to do something. Actually, the law says they have to spend a minimum of 3 minutes on it. I think it's kind of funny that a human, it has to be a human. So AI can't automatically do that for you per the regulation. All right. And if your investigator says, yeah, it looks suspicious, they have to fill out a SAR, suspicious activity report, and they file it with the government. That's the U.S. Treasury or FinCEN, Financial Crimes Enforcement. Now, if they decide, nah, it's not suspicious, they still have to fill out a report. It's not a SAR, but they have to fill out an internal report because, especially if you're in bank number 1, like I was talking about earlier, who doesn't file things, when you get audited and they say, I want to look at, we got Brooke right here, I want to look at Brooke's transaction to this person for $12,000, you got to be ready to defend. First of all, did your TMS system catch it? And second, if it did catch it, why are you saying it's not suspicious? Just anecdotally, we're in North Carolina. We're in good shape here. In Florida, there are a lot of cash transactions. And there's a lot of cash transactions that end up in the no SAR file that maybe shouldn't be. But that's another talk. All right. So what is money laundering? I'm going to use money laundering and fraud interchangeably. And the people the bad actors, I'll call them fraudsters, call them other things. So what is money laundering? Let's take a look at, here's just 4 examples. There's lots of different things that they could be. The first example is an example of embezzling or skimming, where you have an employee at McDonald's and suddenly they deposit $35,000 in cash to their account. Is that suspicious? $35,000 for a low wage earner is a lot of money. That could be your salary. So that in itself might be. Maybe they say, oh, my uncle died and left me all this cash. All right. But when that same person deposits another 35 or 24,000 just a month later, now we have suspicious activity. All right, the next type of fraud is called structuring. Now, if I suddenly get a hold of $49,000 because I sold something that perhaps wasn't mine to own, and he gave me $49,000 in cash, I've got hot money. So how do I get rid of that money? I want to use it. There's a boat I want to buy. So I have to get the money into the financial system. So this is a pretty common technique. I'll just deposit $4,900 10 times. So that way, because I'm smart, you see, I know that dollar amounts over a certain dollar transaction automatically reported to the FBI. So if I do smaller, it used to be 5,000. Actually, I wrote 5,000 up here. I think it's actually closer to 10,000 today. But so if I put it in small amounts, the FBI won't know I. So that's called structuring. The next one's called layering. So I'm a fraudster. I have a whole bunch of accounts. So what I do is I put my money, $10,000 into these different accounts, and I then transfer all that money into one account, and then from that account to another place. Of course, these are in different banks because as a fraudster, I know better than to do all my banking in one place because they'll put the pieces together. So if I do these transactions at different banks, they don't talk to each other. Of course, law enforcement's putting together all the pieces, but that's called layering. And lastly, it's a car wash. Wash deposits anywhere between 14,000 and 19,000 a day, we'll say. Now, it could be that that's a little bit high. Car wash really earns that much money a day. But what becomes suspicious is when they do it every single day of the year. Major holidays, $19,000. Snow day, $19,000. This type of fraud is called money laundering through cash-intensive business. Yeah, literally. Laundromats can be money laundering. Diners, casualty business. So the bottom line, what these fraudsters are trying to do is they have a large amount of money, whether it's $49,000 or $49 million. They have a large amount of money, and they need to break it down into small amounts to get it into the financial system and then reconstitute their money. That's what they're doing. That's what my graphic is supposed to be trying to show off too. Right. So what I just covered there is how people did fraud 50 years ago. That's basics. I just showed you that. That's just getting started. But these guys are getting more and more sophisticated. So about a little over 20 years ago, the TMS systems became automated, and the banks really like that because now you don't have to pour over the transactions. You can actually have a supported application that can flag alerts, so your investigators can look at that. But that about 10 years ago, the problem is that you have to keep caring and feeding that thing, and so you have to keep changing the rules. And every time you change the rules, it seems that you're getting more and more junk coming through, more and more false positives or false alerts. So you throw more investigators at it. You got more to process. Well, here we are 10 years later, and you've been tweaking it even more. Fraud is becoming more sophisticated. The number of ways money can move around is more complicated. Think of Zelle. There's a lot of different payment systems these days. So now, what are they going to do? Do they keep throwing more and more investigators against the problem? That's why banks are looking at, or financial institutions are looking at, how can AI help them? So let's take a look at what it looks like for AI to help these people. Have there been any questions up to now? Yes.
Some examples of what modern day
Okay. Modern day fraud.
Miami.
I'll tell you. I'm on the side that's doing detection. I'm on the side providing software for detection. I'm not actually the guy who works closely with them. It's a friend of mine that does. But no. So I'd love to give you an example of a sophisticated fraud technique, but maybe he's the correct guy. So let's look at see how how it looks, what applying AI to the problem looks. Right. So here we go. This is a juicier slide. What we have is we have the same source of data, same thing. But now what we do is we now have a data pipeline, because you can't just plug data into AI. You really have to prepare your data. And that data preparation process is called data pipeline, data engineering. And what the kind of activities you do, and this is just, if anyone here is familiar from machine learning and looking at this going, man, Anthony's hardly touching on the list of things that are really, really going on here. But these are the biggies. So data correction. Somebody's in your system and they're actively depositing and they're 150 years old. The bank will operate, but it's an error and it's to be corrected. Data normalization. If you're getting data from multiple places, one might be using one terminology and another system might be using different terminology. So normalization brings that together. Feature generation. So, and kind of data augmentation, these two kind of go together to add more to data. Because we're talking about a transaction. What's a transaction? It's a dollar amount. It's a person. It's a person sending. It's a person receiving. And what else? Well, it can be a lot more things. What we can do is with data augmentation, we can pull things like we can do calculations. What's the net worth of the individual? How many deposits have they made in the last 7 days, last 30 days, last 60 days, last year? What's the size of it? What's the size of how much they've withdrawn? Fraudsters like to maintain very low balances for some reason. Let's see. Okay. And then from features, we look at the historical data. So we know in the past what transactions were deemed suspicious because they were filed. And so when we have our data set, I should say first, our data set ends up being something like 50 to 4,000 data points for each transaction. We do that much feature generation augmentation. We want a lot of information around that transaction because with AI can balance lots and lots of variables. So we want to throw lots of variables at it. We don't know which ones are the network of the individual, because that's something we even know. So we just throw lots of different things in here, and where there's correlation, we will pick that out. AI is really good at picking that out. No. 50 to 40,000. 50 to 4,000. Yeah. And at one company I saw, when I first joined the company, they said they had 2,000 features. And then, I don't know, it was like a year later, I said, oh, you still have 2,000? They're like, oh, we're up to 3,500. I'm like, the engineers are just going nuts. But the thing is that the more you know about it, really, a regular English way of referring to features is observations. When I look at a person, what do I observe? Am I observing simply their hair color? Very low observation. Am I observing hair color, length of nose, scars, just da. All those things you can, I'm looking at a person, you can presumably guess. You add all those things in, so then when I'm making generalizations about this person, is this person like that person? And go through, oh yeah, they have the same set of scars. Oh, AI finds that. Us humans probably aren't noticing the scars so much as we're noticing the hair color or something else. It's all data driven. All right, so what we have is we take all that data and we push that data into AI, up to 4,000 points per record, per document. And we know which records are the suspicious ones and which ones are the not suspicious because that's the way they filed in the past. We use that information to train the AI. Oh, we didn't get the color. It says classify in the white box. It says classify. And then after it's been trained, when we give it a transaction, it'll spit out a score. AI loves spitting out scores. So I give it a transaction and I say, how do you rate this for suspicion? In this particular example, I've got 6.3. What's a 6.3? The data scientists are the ones who really analyze the numbers, and they're the ones who come back and tell us where that blue triangle is. Blue triangle here is, we'll say 7.5. So when I get a score of 6.3, that's below my threshold. That's not a suspicious transaction. That one's fine. Don't need to worry about that one. If it scores above 7.5, okay, we need to investigate. Take a look at that. All right. So this is more of a technology slide. Let's now take a look at what does it look like when we put this. Yes?
just wondering, are you still meeting the 3-minute threshold for somebody reviewing?
Just technology here. Right. So a 3-minute, we'll take a look at that next slide. Do you have a question?
Well, so those features don't necessarily have to come from within your organization. It could be, I'm just making stuff up, Dun and Bradstreet, other sources, metadata. You could be getting that side. You're just pulling that together in-house, what you're calling features to augment that, have metadata, whatever you call it, so that you can classify it, right?
So Jerome's asking, is the data that's flowing through here only data that we have in-house, or can we actually bring in data from outside and add that too? Absolutely. If you have it, in fact, for example, there's organizations like LexisNexis. They provide data, and I'm sorry if they compete with you, and I didn't mention the company. I'm sorry, but given an individual, you could go and query LexisNexis and pull down information like the credit history, things like that, and pull that in there. Absolutely. Yeah, whatever information you have, you can attach to it.
Just follow. If there are trends, some of these are groups of individuals and they're doing something in Florida and then that group moves, and is there databases or sources that maybe with the government reporting new trends or new things to help make sure that you are factoring that in your scoring?
So what I'm hearing you say is, does the government provide you information, perhaps trends or additional information that you can add into here? The relationship that financial institutions have with governments with respect to fraud detection is pretty much one way. You collect up your reports, you send them to the government, maybe the government says thanks, but the government never gets back to you. If they do get back to you, it's usually a police officer saying, we'd like a little more information about this particular transaction. But things like loops, finding gangs, finding rings, fraud rings, that's outside the wheelhouse of financial institutes. They're not asked to do that. One more thing is we worked with a bank in San Antonio, Texas. Won't name them. They what they did was our engineers went in there in a previous company. Our engineers went in there and they actually found that they were looking at car insurance fraud and medical fraud, and they actually found rings. But it was for the bank. The bank's like, government doesn't tell us what to do with rings. You can't file a ring report. So although it was really cool that the guys were able to find a fraud ring, there was no mechanism for communicating that to the government. So, and they weren't in that business, so do they really want to spend resources on that? So, question here.
Sure. They're actually not specific observations, right? Because there are some federal law, regularly some kind of right? Because you have to maybe do a like age or gender, or there's AI fairness kind of, some bias of the models nowadays people are using. That's not fair for all population. When this kind of happening, we cannot actually use.
So is that a question or is that a statement? Okay. So she was just saying that there's certain types of information that AI is not allowed to process, perhaps age, gender, race, something like that, or ethnicity. Actually, I wasn't aware of that. So, okay. We take the data that our customers give us. So if they give us age and ethnicity, it's just another input. If we're not supposed to, it's easy for us to just chop that out.
A lot of system are buying vendors instead of themselves are communicating those kind of things using interpret, so they want to avoid this kind of regulation from them. That's just one part of it.
Interesting. Okay. Yes.
SC standard, or is this for few lines, or is it baseline and then customize it for different lines?
is asking, is this true for all AI, or is it just guideline? This is just basics. Mm-hmm. Yeah. And a technical peer who looked at this would say, Anthony, you oversimplified that. Why didn't you put up the big diagram that had 30 boxes on it? I'm putting up the smaller diagram because this is the basics here. All right, so and this is the technology. So we're really looking at the technology here. What I want to do is next look at how does that technology modify the process. So we saw that process diagram before, starting with the transactions all the way on the left, and then the investigation team on the right. So how does AI change that? So this is kind of interesting. AI doesn't get in the path, but AI augments the path. AI pulls those alerts, and remember from the last slide, we saw that we took the transactions, we did our data engineering thing, and we created a model inside the AI engine, whatever that was. And then now the AI engine takes the alerts, that transaction, it looks at it, and gives it a score. In our previous example, it was a 6.3, but whatever the score is on each transaction. Now, with all of those alerts ranked, the investigation team can tackle the highest scored, the highest ranked alerts first. They're going to spend their time where the actual suspicious activities happen. And some low numbered score, you don't need to worry about it. Now, actually, I say you don't need to worry about it. In general, you don't need to worry about it, but in actuality, you have to make sure the AI is working properly. So what I find is the financial institutions, what they do is they'll randomly take a sample every so often. They'll just take some low scoring alerts, and they'll investigate those as well. And if any of those alerts start coming out as suspicious, wait a minute, apparently our threshold's at the wrong level, or the fraudsters are changing, they're doing something different. And so that means you got to go back to the model and rebuild the model. But we'll get to that in a minute. I think this to be a survey of all the different ways AI can be used for fraud detection, but I don't have experience with all the different types of AI. I'm aware that fraud detection uses two types of AI. I'm aware that it uses machine learning, which by far is the vast majority of what people use. It's, in fact, when I mentioned cognitive reasoning, I wonder if there's anyone in this room that could actually raise their hand and say, yeah, I've heard of cognitive reasoning. It's pretty good. Yeah. Yeah. So it's niche. It's definitely niche. And it's kind of funny because when you look, I worked at Intel Corporation for actually Intel Corporation acquired a Cary-based company called Saffron Technology. So it was the group I worked for was Intel Saffron, and it had its roots here in North Carolina, Cary. If you looked at the spec sheet of how the cognitive reasoning software, you looked at the spec sheet and the marketing literature of how it looked for machine learning, it's really hard to tell the difference unless you are familiar with the two technologies. The sheets look the same, so it's actually kind of interesting that way. From my perspective, the technologies are very different, but how they're applied is very, very similar. All right, I put this little arrow over here. Coincidentally, it's the same. So Intel Corporation acquired Saffron, and I was part of the team there. And then, if you remember, Intel Corporation is a CPU company. After 3 years, they give every software company 3 years, and then they shut it down, it seems. And so they shut down our group. So that's precipitated to the jump to Tukitaki, which went from cognitive reasoning to machine learning. But then here, some of the former Intel Saffron people have said it was good technology. People could really use it. So now we have a new company that's Cary-based, Poly-based. I'm not sure what we're considered. And it is coincidentally the same. All right. So let's look at machine learning, and let's look at cognitive reasoning. So if you were to deploy a machine learning solution, it would look something like this. First, you have to gain access to private data. And it's like, well, yeah, of course you have to gain access. Everyone knows that. I put it up here because when I work with customers, I can arrive and say, okay, you got the data, and they say, oh, last night we hit a hitch. The VP of the division that has that data won't sign off on the data because they're trying to figure out the transactions, the customers. This is core, very private information. So when you gain access to private data, you have to really, there's a chain of custody. That data has to securely go from system or whatever. Hopefully it's direct to the target system. And then you have to nail that target system down. So it's a non-trivial step. So that's why I can put it up here. Okay, extract metadata. A couple slides back, I was talking about data engineering, talking about features. So that's the next thing you do. After that, for machine learning, you pick a model. Common models have names like regression, tree-based, clustering, Bayesian. When I was at the Tukitaki company, we had 15 models, 15 different models. If anyone's familiar with machine learning here, I'm sure it's 30 or something now. There's lots of different machine learning models. Just because you're using machine learning doesn't mean you're doing the same thing as everyone else. All right, once you picked your machine learning model, then what you need to do is every model has parameters. Some models have 1 or 2 parameters. Some models have a dozen or 20 parameters. Data scientists play an important role here because what they do is they're trying to maximize recall. We'll get back to that. But what they're trying to do is in maximizing recall, they're tweaking their parameters. And then once they got the parameters, they say, okay, these are the good parameters, which when the fraudsters change what they're doing, those parameters may not work anymore, and the data scientists have to come back. For right now, we'll just call it recall. We'll say it's a meaningful, it's a measuring stick for checking our model's ability to recognize suspicious activity. We'll just call it that for now. We'll go back and give it a better definition of that. All right, so you picked your model, you got the data scientists that give you the parameters, and now you have a model that's built. It takes hours to build these models, a lot of compute and hours. Later on, 6 months down the road, perhaps, you then have to rebuild your model. Bring data science back in, rebuild the model, takes hours again. But the bottom line is that you have a model that can then classify alerts, typically in batches. Right? So that's what machine learning looks like. With cognitive reasoning, it looks very, very similar. In fact, what's in boxes is exactly the same as the previous slide. So again, gain access to private data, extract data, metadata, that's the data engineering phase. Now, here's where we see the difference between the two. Machine learning likes numbers. It chews on numbers. And whereas cognitive reasoning doesn't know what to do with a number. So with cognitive reasoning, what we have to do is we have to convert numbers to labels, which can be something like, small, medium, large. That's a simple conversion. If it's something like individual's net worth, then what we do is the label is usually like a range, $10 to $100 or whatever it is. Because it deals with labels, it can deal with text. So cognitive reasoning can actually, for a transaction, the teller may have made some notes. Like the person had a lot of perfume. That was actually actual teller note. And it turned out to solve a crime, actually, but that's another story. The teller, the notes, any notes associated with a transaction can be in there. The customer profile could be in there. Hopefully not the race or other data that's not allowed. Any information, government information, whatever information you can pull in, can all be pulled in, and the text, you can actually work with the text, right? Then I'm most familiar with the ADE product, so we then load the data into ADE. That does take hours. Large amount of data does take hours to load. But once you have all the data loaded, incrementally adding more data is actually is a small amount of time. You don't have to reload the whole thing, which is a difference from machine learning. Here's another difference with machine learning, is that with machine learning, you build a model. You have to have a data scientist who picks the model, tweaks the parameters, and so forth. With cognitive reasoning, it doesn't actually have the concept of models. In fact, some people have called it where it creates the model on the fly, which kind of strange. And for fraud detection, what we do is we create 2 labels. One is SAR labeled data. So we create a signature based around all those transactions that were filed as SARs, as suspicious activity reports. And then we create another signature around the non-suspicious data. the non-SAW reported. And then lastly, with cognitive reasoning, you can classify either singly or in batches your various alerts. Now, we recently worked with a customer, and I'd love to say worked with the customer for the machine learning part, so that I have a chart of how their machine learning worked versus how the cognitive reasoning piece worked. They didn't give me access. In fact, actually, they didn't disclose until more than halfway through the project that they already had a machine learning project. So here we are thinking we're creating something for them, and meanwhile, the whole time we're being compared to another project. So, but when it came time to present to the signature authority on the proof of concept, these 4 things are what they reported. So I'm going to paraphrase. I'm not reading slides. I hope you guys didn't want me to come and read the slides. And some of you who do read slides are probably like, Nancy's not reading them in order, things like that. Sure. Also, I'm trying to say things verbally that are not on the slides. I'm trying to make this useful for you. All right, so the first bullet, what they said, which really surprised me, was it took half the labor as machine learning. I thought that was so interesting. The second thing they said was that the more signatures they created, the more useful the AI tool became. And the subtlety there is with machine learning, when you build a model, it's a single purpose model. If you want to look at the problem differently, you have to create a new model to look at the problem differently. So there's a model creation, and here with signatures, it pivots very quickly. The third one, additional suspicious alerts that weren't alerted were found. So what they did was they said, we just created, that was the previous slide, we created a signature of all the suspicious alerts. And then what we did was we applied it to all the transactions that were never even alerted. So the TMS system said, they're good, you don't have to look at them. So they said, okay, what does that look like? We pulled the top 20 most suspicious. It's one of the calls you can do. And the manager looked through it and said, wow, I need to get these to the investigators. These look suspicious to me. So it was interesting. These calls happen very fast, so you want to play what if scenarios, it's really easy to do that. Let's see. Lastly, there's a feature, since it creates the model on the fly, what you can do is you can say, here's a transaction. I want you to create a signature, in a sense, a model. I want you to create a signature around this transaction. So it could be that you just found out there's some new sophisticated technique for fraud. Now, the software doesn't understand what fraud is, per se. It's AI. AI is looking at all the documents and what you're calling suspicious. And it says, I find more similar things like that. That's all the software is doing, just doing it powerfully. But perhaps there's a new fraud technique. And so you know, this transaction, this is funky. So you can create a signature around it and then say, what other transactions are like this? It'll just come right back and say, here you go. There's 20 other transactions that have the same appear to be like that. Send them over to the investigator team. Yes, Drum.
So, Anthony, when you say that, it made me think, because I work in a different area, it really sort of made me think that this would be also how you would identify virus, right? And in virus, the virus, right? Like malware, like so. What they do there is they have a whole team of people developing these signatures, and they release them monthly updates to say there's a new dictionary of more viruses.
Okay, so Jerome was comparing this to viruses. I don't have experience with viruses, but viruses strike me as very specific and very detailed. But again, I'm not an expert at that. Where AI really is there's statistical analysis going on. So I think it's a different beast. But it's not my area of expertise, so I don't know.
No, what I was just saying is the fact that you identify, let's say, 20 different anomalies or things that look like a certain pattern or an indicator that this could be fraud, right? It sounds like that would make it so much easier for that say, hey, I'm checking for these things now, but if next month a new way of doing things comes out, you just now to it, keep checking what I have, plus the new stuff, and not have to redo your whole model.
I'm with you. And the short answer is yes, because really the core software is not financial specific.
Yeah.
If you have documents, and it sounds like what you're describing there is you have the antivirus scenario you've got there is properties about, I guess, symptoms. Symptoms, and certainly it can pick up symptoms and say this symptom pattern looks suspicious. You do that. All right, I need to pick up the pace, otherwise Brooke is gonna give me the hook. All right. Did I cover everything here? Oh, well, customer quote. I remember I said at the very beginning that I wake up every day and I'm excited to go to work because I like making a difference with my customers. And when my customer said this, I had to write it down. He said, when ADE is applied, the product is applied, it would reduce the volume by half. It would cut their work volume by half, and while still maintaining a 97% coverage. And that, it's 100% would be ideal, but it's unrealistic. His threshold was 97%. I thought I was very happy with that. Right. Let's the remainder or the next few slides. I'm gonna get more technical on you. All right. So how does ADE work? Maybe you read an article about machine learning, and so you know that it reduces, it does statistical reduction and models and all that. Well, here's the basic inputs of how ADE is working. And while I'm talking, it helps if you look at the diagram at the bottom here. So here's an attribute, a feature you could say, that is a category and a value pair. And here's a series of them. Here's a document. All of them together makes a document. Here's another document, another document. All these documents are in what's called workspace. You can have multiple workspaces. So this is how the data, when we're doing our data engineering, we end up with data that looks like this. Right here, high gross margin, low OpEx. True. That's a piece of metadata that was pulled from somewhere. Let's see. So it kind of looks like this is a record, like a database record. And if you want it, you could pull a database and stick it in here. But it's fundamentally not a database record like a relational database. Document 2, it is the ticker is the category. It could have no value at all, just not be there. It can have multiple values. In this case, a ticker is a unique identifier, but you can have 0 or more values. Another thing is that with cognitive reasoning, it doesn't forget a thing. Machine learning does a statistical reduction. All right, I'm going to get moving. All right. Confusion matrix. This is tied back to that word recall. I could spend some time on this, but I think I'm gonna skim over the slide. Bottom line is that word recall. I want to maximize recall. So what we do with data scientists do with the data is they look and they say, I gave you a transaction and I knew the transaction was suspicious. What did you say? Did you say it was suspicious or did you say it was not suspicious? So if we got it right, it's a true positive. If we got it wrong, it was a false negative. What recall does is it compares how many of the suspicious things I gave you, how many of them did you actually get? And in this case, 97% of them for that customer quote, 97% of them we got it right. Now, what happens is false positives creep in here. False positives are where we predicted it was positive, it was suspicious, but it really wasn't. It actually is negative. It's not as big a deal. It's work. It's not as big a deal to mess up and have false positives because you do have a human team that is investigating them. And the human team will say, this isn't suspicious. All right. And with financial institutions, the risk is around true positive. It's more expensive for a financial institute to miss a whole bunch of them because that's when the government comes in and says, why did you call this suspicious? We didn't think it was suspicious. Our software told us it's not suspicious. Not a good answer. And that's when the fines come. All right. So, okay. Our AI model has given us a score, a number. What do we do with that number? There's different things we could do with it. And the data scientists tell us what's the best way to calculate it. In our case with cognitive reasoning, Dr. Kolmogorov was a brilliant mathematician, and he came up with the Kolmogorov formula. It's set theory stuff, and that's what's going on behind the scenes here. So when we do a calculation for a score from a signature, so S1, signature 1, a score 1, whichever, the Kolmogorov algorithm is used to give us that number. And when we have that number, maybe what we do is we just use the suspicion signature. What's the score of the suspicion signature? And you see a simple chart here with the blue triangle, and that's our threshold. If the score comes back above the threshold, aha, it's suspicious. If it comes back below the diamond or the arrow, then it's not suspicious. And the data scientists tell us that. So, okay, great. And it's as simple as that, figuring out if it is suspicious or not suspicious. But maybe you want a little more sophisticated. Maybe what you want to do is you want to calculate two signature values. You want to score from suspicious, and you want to score from not suspicious. Whichever one's the bigger one, that's what we'll predict it as. Now, this works well for a balanced set of data. If we had a lot of suspicious and a lot of not suspicious data, then this would be a good approach to take. But in general, with detecting fraud, that's not what you have. With the customer, in the recent customer engagement, we actually used this third one here because they had 1 million data points. They gave us 1 million data points, and out of those 1 million data points, 215 were actually suspicious. So that's 0.02% were actually suspicious, compared to 99.98% that were not suspicious. This is very unbalanced. We call this sparse data, and it's really hard to work with data like that. In this particular case, what we did was we calculated the score for the lower number for suspicious and the score for not suspicious, and we needed to boost the signal is basically what you need to do. And the way we chose to boost the signal here is we actually looked at the gap between the two. And with that, we were able to achieve 97% recall. So we were happy with that. That was basically, we concluded this is what we'll do with their data set. All right, so I keep saying cognitive reasoning. Sometimes I say ADE. ADE is the product name. It's AIXI Discovery Engine. And what is it? So real quick, what we're looking at is ADE it has a REST API to talk to it, but you don't have to do the REST API. It also comes with a Python module. So your Python program can just talk to the Python module, and the rest is happening on the back end. The product itself is a series of 4 Docker images that are Kubernetes ready. That's our client actually had Kubernetes. And we have a user interface. The tool pod, that is really the data engineering piece. The REST pod, that's the front end. And then you have as many processing nodes as you want in back end. So it just scales to whatever you want. All right. So I'm running out of time. I do want to be able to take a question or two, hopefully. And let me just conclude with, how did we get here? We got here because financial institutes are required to report suspicious activity to the government. And the TMS systems are generating too many false alerts, and they need something to help their situation today. What we find is AI actually does improve fraud investigation by scoring every alert, so that they only need to work on the higher rank, the most suspicious alerts. And in particular, with cognitive reasoning versus machine learning, we learned that it works well with sparse data, and we learned that it was quicker to implement the machine learning. That was a surprise. I did not see that one coming. Did I miss anything? Are there any questions? Yes.
Get the feedback from, say, false content, recommend they're saying that is not true. How often do you get that to retrain the model?
So the question is, how often do we get feedback from the investigators as to whether things are suspicious or not suspicious? So as alerts are filed, we go back to the data and we flag them. That was a suspicious transaction, and so we're continuously adding, flagging it in the data, but it's not going to be applied until we rebuild the signatures. So, but I think I forget the last time I rebuilt some signatures for that million data point thing, but it was like 2 seconds or 4 seconds. So it's really more of a scheduling thing to run it at night or something like that. So you could do it daily. Yes.
So, client come back to you, but you guys have the data science skills to recreate the model, or do they create them on their own?
It's the people that are deploying machine learning. They have a data scientist. Um, yes. Because they don't want to have to keep coming back to us. It's their beast, and they want to manage it. So, and here it's with machine learning, you definitely need a data scientist because they have to understand the parameters of models. With cognitive reasoning, we don't have the models, we don't have all those parameters. So really, it's just a matter of recreating the signatures, which can be automated. Machine learning or cognitive reasoning? Cognitive reasoning, you can retrain daily if you want it. And we say the word retrain, that's really a machine learning term. In cognitive reasoning, it's just recreating signatures. With machine learning, to retrain machine learning, it's probably a couple week process with data scientists, and it's probably computing time at least 24 hours of computing straight up just to get the model. So it's different. Yes.
Yeah, but
Can you speak up a little bit?
you're working with a bank and it's something that similar to generated here and maybe nothing.
It's an interesting question. Instead of using the bank's data, can we instead use another data set, create the signatures, and then apply those signatures on bank data? The short answer is actually no, because, well, I don't have the diagram up there, but the investigators, different banks, different financial institutions have different clientele. And it basically, I'd love to be able to say, yes, we just released, here's the latest signature for catching the fraudsters, and we just, on a subscription basis, keep giving you that. But we can't do that for a couple of reasons. One is we're working with your data, and your data may have these things, but not have those things, and the other client has those things. So we have to work with what data is in each group, and then the clientele, things could be a little bit different. In particular, like if I had a North Carolina bank and a Florida bank data sets, the data set for fraudsters in Florida is going to look really different than the fraudsters in North Carolina. We don't deal with so much cash.
There are different features for different data sets. So if you do some kind of internal benchmarking based on just that you get then you get from card and then you go similar to internal benchmark.
I love what you're thinking.
Is what it is.
What you say is, correct me if I'm wrong, but there's got to be subsets of data that are common. So can we rank it or things like that? I like what you're thinking, and I think that's a bit ahead of where we are today. We need to deploy a few more customers, and there's a bit more work to be done. But I like the direction you're thinking. It's more of a compartmentalized approach. Now, having said that, just because I like it, the Kolmogorov algorithm, the way it processes things, is it uses entropy. So it's looking to see how frequently something shows up, or how infrequently something shows up. When something shows up infrequently, then it becomes strong. When something shows up all the time, then that's weak. So I just be worried. Again, it gets back to can we really standardize that, or how unique is each financial institute? I think we have a question for one more. We have time for one more question. Yes.
I was wondering, what is the gold standard fix? Suspicious thing that I would think suspicious. Like I'm sort of suspicious, bring the model to get as close to that as possible. Or is there like a feedback loop that goes and checks to see, okay, these are what I don't suspicious. Done that, yeah.
I was expecting. So the question is there a feedback loop or an authority that says what's suspicious and what's not?
I know that this is suspicious. I try to bring the mark to get as close to that as possible.
So our gold standard here is, did this alert cause you to send a report to the government? That's the gold standard. And if the answer is yes, then that puts that alert in that category, and that becomes part of the group that is the suspicious activity group.
That's the difference between suspicious and actual fraud.
Oh, we don't know. Well, we're sending to the government. We don't know if people were actually prosecuted or not.
Then goes to someone else, and there's nothing that's back model that says, yeah.
The government provides us no feedback. Maybe the newspapers do, but the government does not. Yes. Thank you very much. Appreciate it.
We'll be around for another 30 minutes or so, so feel free to continue networking and enjoy yourself. And don't forget about the Cybersecurity Summit. If you did not get an email and you remember, reach out to us. Right? Thank you very much, and we'll see you next month.